Good evening, and welcome to Dream Theatre for a relaxed mind. Lay back, turn out the lights, and put on the kettle. Coffee, tea, or perhaps something even more ambitious. Tea and Gravity, a little corner of the universe where we let science take off its lab coat, put on its fluffiest dressing gown, and make itself a warm cup of something soothing. I'm Professor Teabottom, former astrophysicist, current tea enthusiast and biscuit philosopher, and tonight you and I shall journey into the delightful and surprisingly dramatic story of our solar system. Before we tumble headlong into tonight's sleepy tale of science and softly simmering wonder, a small request from your ever-thirsty host. If you find yourself enjoying these curious bedtime ramblings, do please like this video and subscribe to the channel. You see, the cost of decent tea these days is climbing faster than a startled electron, and if you've a moment more, consider joining our free Substack. There you'll be notified the moment a new episode appears, and you'll gain entry to a rather cosy salon of discussion, where we share thoughts, swap ideas for future episodes, and occasionally argue politely about whether gravity has a favourite biscuit. The link's tucked in the description like a note under a teacup. Now then, let's begin. Welcome, dear listener, to what can only be described as the most dysfunctional family reunion in the entire cosmos, the solar system. Imagine a family gathering where everyone is a bit odd, a touch eccentric, and quite possibly plotting their next dramatic exit. Except these relatives are planets, moons, asteroids, and the odd dusty comet thrown in for good measure. At the centre of this rambunctious clan is the Sun, a fiery, attention-demanding patriarch who insists on being the star of the show, quite literally. Without him, the family might just drift apart, but instead they spin and dance in his gravitational grip, caught in a cosmic ballroom drama that's been running for about 4.6 billion years. Yes, that's older than your great-great-great-grandfather and considerably more persistent. Our story begins here, with introductions. Picture the solar system as a vast, sprawling manor. Some rooms are tidy and well kept. Others, well, let's just say they've seen better days. The inner circle is compact and intense, with Mercury, Venus, Earth and Mars all vying for attention, while the outer realms host a wild party of gas giants and icy wanderers. Each member has their quirks. Mercury, the twitchy middle manager, can't stop darting around the sun like it's late for a very important meeting. Venus is the sultry sibling who's always too hot and rarely appreciated. Earth, our beloved tea drinker, strikes the perfect balance, while Mars broods in the corner, stirring up dust and dreams of colonization. Further out, the giant gas planets, Jupiter, Saturn, Uranus and Neptune, lord over enormous domains, each with their own entourage of moons, rings and storms. It's the kind of family where the in-laws alone could fill a book or a trilogy, and the cousins are so numerous you'd need a lifetime to meet them all. Then there's the asteroid belt, the attic where all the unwanted bits got shoved, creating a chaotic jumble of rocks and dwarf planets. Beyond that lies the mysterious Kuiper belt and Oort cloud, the distant relatives who show up only once every few millennia, if at all. The Sun, of course, is the fiery nucleus of this cosmic family, a relentless ball of nuclear fusion, constantly radiating energy and demanding attention. It's the sort of figure who refuses to let anyone forget who's in charge, whether through solar flares that put on light shows or gravitational tugs that keep everyone on their toes. The Sun's magnetic personality is quite literally magnetic, pulling planets into orbit and keeping the family together, for better or worse. Now, if the Sun is the family patriarch, then Mercury is the hyperactive middle child, zipping about at breakneck speeds. No one's quite sure if it's trying to outrun the Sun's intense gaze or just anxious to prove its worth. At a mere 4,880 kilometres in diameter, about the size of Texas, if Texas were a very lonely planet, Mercury is small, fast, and heavily cratered, the cosmic equivalent of a jittery office manager who's seen one too many budget meetings. Venus, by contrast, is the glamorous but misunderstood diva. Draped in thick clouds of sulfuric acid and smothered by a runaway greenhouse effect, Venus broils at surface temperatures hot enough to melt lead. She's the family member everyone talks about in hushed tones. Fascinating but dangerous, with moods hotter than her atmosphere. Earth, our beloved tea drinker, is the comfortable, balanced sibling who manages to get everyone to sit down for a proper chat. With oceans covering most of her surface, a life-friendly atmosphere, and a magnetic field to shield from cosmic rays, Earth has all the right ingredients to keep the family going, at least for now. Mars is the red-haired rebel with a complicated past, a planet of dust storms, ancient river valleys, and dreams of human colonization. It broods quietly, harbouring secrets beneath its rusty surface and tantalizing us with the possibility of past life. The outer family members are the gas giants, Jupiter, the grand patriarch with a retinue of over 80 moons, Saturn, the stylish sibling flaunting elegant rings, Uranus, the aloof and sideways spinner with a faint blue hue, and Neptune, the distant windy loner shrouded in azure mystery. Their presence commands attention, and their storms rage with a fury that puts Earth's weather to shame. Meanwhile, the asteroid belt sits like an overflowing attic, cluttered with space rocks, dwarf planets like Ceres, and the remnants of early solar system building blocks that never quite formed a planet. Beyond lies the Kuiper belt, home to icy bodies including Pluto, and even further the Oort cloud, a vast mysterious shell of icy comets lurking in the farthest reaches. This family, though unruly and sometimes prone to cosmic drama, has endured for billions of years. Their orbits, interactions, and histories weave a tapestry that tells the story of our cosmic neighbourhood. From catastrophic collisions to gentle gravitational embraces, the solar system is a dynamic, ever-evolving family drama, one that we're only just beginning to understand. So, pour yourself a cup of tea, settle in by the fire, or your favourite cosy spot, and prepare to meet each of these cosmic relatives in turn. Their stories are strange, fascinating, and often surprisingly relatable. Because in the end, isn't every family a little bit dysfunctional? The Sun, Father, Furnace, Diva. The solar system's fiery patriarch, part overbearing father, part demanding diva, and all-consuming furnace. Without the Sun, this whole cosmic family would be a rather chilly and quiet affair, more like an empty house than a bustling household. The Sun has been burning bright for roughly 4.6 billion years, long enough to outlast several generations of human relatives, and certainly enough time to build up a decent grudge or two. Its core is a nuclear reactor of mind-boggling power, fusing hydrogen atoms into helium in a process that releases unimaginable energy. This relentless fusion keeps the lights on for the family, and keeps the tea warm, which, as any British person will tell you, is no small feat. The Sun's temper is legendary, prone to sudden outbursts known as solar flares and coronal mass ejections, which can throw a cosmic tantrum strong enough to disrupt satellites, power grids, and occasionally cause spectacular auroras lighting up Earth's skies. It's the sort of drama that makes family gatherings seem like quiet tea times by comparison. These solar storms are a reminder that the Sun is no mere glowing orb, but a dynamic living star with moods as changeable as the British weather. Scientists track these moods carefully, a solar cycle of about 11 years, waxing and waning in activity. Like a cosmic version of the seasons, except instead of daffodils and rain, you get flares and sunspots. Sunspots themselves are the Sun's freckles, cooler, darker patches caused by magnetic fields bubbling to the surface. They're a sign that the Sun is busy beneath the surface, stirring and churning in a dance of plasma and magnetism that powers the whole show. One cannot discuss the Sun without mentioning its gravitational grip, a pull so strong it keeps the entire family in orbit, from the speedy inner planets to the distant icy bodies on the edges of the system. Without this invisible leash, the planets might wander off, and well, that would be quite the family crisis. The Sun's influence extends far beyond gravity and light. Its solar wind, a steady stream of charged particles, shapes the heliosphere, a protective bubble shielding us from interstellar radiation. It's like the family's overprotective matriarch, always making sure no unwanted cosmic visitors gate-crash the party. And then there's the personal side. Imagine the Sun as that grandparent who never sits still, always busy fussing over everyone, sometimes a little overwhelming but utterly indispensable. It's been there since the beginning, watching over billions of years, quietly shaping destinies with its radiant presence. One of the most charming aspects of the Sun is its cycle of moods, the infamous 11-year solar cycle. During the solar minimum, the Sun takes a bit of a breather. Fewer sunspots, less flaring, A bit like that quiet relative who finally gets some peace and doesn't feel the need to stir the pot. But don't be fooled. The sun is never truly idle. Beneath that seemingly calm surface, magnetic fields twist and tangle, storing energy like a cat poised to pounce. As the cycle progresses towards solar maximum, the sun becomes more expressive. More freckles, more flares, more drama. It's the cosmic equivalent of someone having too much tea and too little patience. Solar flares erupt, sending waves of charged particles hurtling through space, sometimes colliding with Earth's magnetic field, triggering those enchanting auroras that dance in polar skies. It's nature's own light show, free of charge and infinitely more dazzling than any fireworks display. These solar tempests can play havoc on our technology. Satellites glitch, communications falter, and power grids occasionally flicker off. It's a reminder that despite our modern gadgets and sophisticated infrastructure, we remain very much at the mercy of our star's whims. The sun, for all its nurturing warmth, is also a celestial diva with a penchant for drama. But it's not all tantrums and storms. The sun's steady, unwavering glow has been a constant companion for all life on Earth. It powers photosynthesis in plants, drives weather systems, and sets the rhythm for the circadian clocks in all living creatures. It's the ultimate timekeeper, as reliable as Big Ben, but infinitely hotter. Interestingly, the sun is currently about halfway through its expected lifespan. Born from a collapsing cloud of gas and dust some 4.6 billion years ago, it has enough hydrogen fuel to keep burning steadily for roughly another 5 billion years. When it eventually runs low, it will expand into a red giant, possibly swallowing the inner planets, including Earth, but that's a very long way off, so no need to cancel tea time just yet. Long before the invention of telescopes, satellites, or even the concept of gravity, humans looked up at the sun with a mixture of awe, gratitude, and downright fear. It was impossible not to. The sun was the ultimate authority, the source of light, warmth, and life itself. Unsurprisingly, many ancient civilizations deified it, crafting elaborate myths and rituals to honour this blazing ball of fire. Take the ancient Egyptians, for instance. They worshipped Ra, the sun god, who was said to travel across the sky each day in a fiery solar bark, fighting off the serpent Apophis each night to ensure the sun would rise again. Imagine that, a celestial boat captain tirelessly steering through cosmic storms, battling serpents so you can enjoy your morning tea. It's both heroic and oddly relatable. Meanwhile, in Mesopotamia, the sun god Shamash was the divine judge, shining his light on truth and justice. Shamash's rays illuminated not just the physical world, but the moral one too. It's a reminder that for early humans, the sun was a symbol of order amidst chaos, the very embodiment of fairness and clarity. The Greeks had Helios, who drove his fiery chariot across the sky each day, his steed snorting solar flames. Later, Helios's identity would merge with Apollo, god of the sun, music, and prophecy, showcasing how the sun was intertwined with culture, art, and foresight. In Norse mythology, Sul was a female sun deity chased by wolves, a cosmic game of cat and mouse that explained the day's passage. This myth gave rise to a worldview where the sun's light was a precious, fleeting gift, forever pursued by darkness. These stories, and many more like them, reflect the sun's profound role in shaping human understanding of the world. The cycles of sunrise and sunset became metaphors for life and death, renewal and decay. The sun was both a nurturing parent and a powerful force to respect, much like the real sun, which nurtures life but can unleash devastating solar storms. What's striking is how universal these sun myths are. Nearly every culture, from the Aztecs to the Japanese, developed rich sun worship traditions. Some even built elaborate structures aligned with solar events, think Stonehenge or the pyramids, monuments to the sun's sacred passage through the heavens. For those ancient peoples, the sun was more than a star. It was a living entity, deserving reverence, propitiation, and celebration. Festivals like the summer solstice are echoes of these ancient rituals, still observed in many parts of the world. So as we bask in the sun's glow today, it's worth remembering that we're part of a lineage stretching back millennia. A long line of humans who looked skyward and saw not just light, but life, power, and the divine. For those of us lucky enough to gaze up on a clear day and see the sun shining warmly, it's easy to forget just how remarkable this fiery sphere truly is. It's a nuclear furnace, a magnetic powerhouse, a gravitational anchor, and a cosmic storyteller all rolled into one blazing orb. So next time you find yourself in the warmth of the sun's rays, whether sipping tea or simply enjoying a quiet moment, remember the grand star above, a tireless, temperamental, and utterly indispensable family member. Mercury, the solar system's equivalent of a jittery middle manager, small, twitchy, and perpetually running late for every meeting with the sun. It's the closest planet to our fiery patriarch, which unsurprisingly makes Mercury a bit nervous. Imagine trying to keep cool while standing just a few million kilometres from a raging furnace that never takes a break. At a mere 4,880 kilometres in diameter, roughly the size of Texas, if Texas were a very lonely planet, Mercury is the smallest of the official planets, and also the fastest, zipping around the sun once every 88 Earth days. This speedy orbit earns it the nickname of the fleet-footed messenger of the gods, a cosmic courier darting tirelessly on its rounds. Mercury's proximity to the sun means it faces some rather extreme mood swings in temperature. By day, surface temperatures soar to a blistering 430 degrees Celsius, hot enough to melt lead and, frankly, scorch any tea kettle foolish enough to sit outdoors. But don't get too comfortable. When night falls, the temperature plunges dramatically, dropping to a frigid minus 180 degrees Celsius. It's the cosmic equivalent of switching from a blazing hearth to an icebox in the blink of an eye. This wild temperature swing is due to Mercury's lack of a substantial atmosphere, or more accurately, its near-total absence of one. Without an atmospheric blanket to trap heat, the warmth from the sun bakes the day side, while the night side is left shivering in the dark. It's a bit like living in a house with no central heating or insulation, and the windows open all night. The surface itself is a pockmarked landscape, resembling our moon with countless craters from billions of years of asteroid impacts. These craters are silent testaments to the solar system's turbulent youth, where collisions were common and space debris roamed freely. Mercury even boasts the Caloris Basin, a colossal impact crater nearly 1,500 kilometres wide, roughly the size of Texas, which is a cosmic coincidence that might just be Mercury's way of showing off. Mercury's spin is another curiosity. Unlike most planets, it doesn't rotate on its axis once per orbit, but instead follows a 3-to-2 spin orbit resonance. This means Mercury rotates 3 times on its axis for every 2 orbits it completes around the Sun. The result is a slow, somewhat disorienting day-night cycle, with some places experiencing sunrise, sunset and sunrise again all in a single Mercury day. It's the kind of quirk that would make any manager double-check the calendar. Mercury's magnetic field, surprisingly strong for such a small planet, adds another layer of intrigue. Generated by a molten iron core, this magnetic field deflects solar wind particles, creating a tiny magnetosphere. It's Mercury's way of holding a modest shield against the sun's relentless onslaught, a little umbrella in a storm of solar fury. Observing Mercury has been a challenge for astronomers due to its closeness to the sun. It can only be seen during twilight, appearing as a fleeting, shy visitor in the dawn or dusk sky. The ancient Greeks and Romans noticed this swift-moving light and named it Hermes and Mercury respectively after their quicksilver gods, a fitting tribute to its speedy journey. One memorable quote comes from the great astronomer Johannes Kepler, who described Mercury as a curious and mischievous little fellow, darting around the sun like a flash of light. Indeed, Mercury's capricious nature has long fascinated stargazers. In the modern era, the Mariner 10 mission in the 1970s was the first to provide close-up images of Mercury, revealing its cratered face and geological features. More recently, NASA's Messenger spacecraft orbited Mercury, uncovering evidence of water ice in permanently shadowed craters near its poles, a surprising oasis in this scorching desert world. Messenger's findings challenge previous assumptions, showing that Mercury is far more complex than a barren rock. Its surface bears mysterious hollows and unusual terrain, hinting at ongoing geological activity, however faint. It's a reminder that even the smallest members of the solar system family have secrets yet to reveal. I often imagine Mercury as the diligent, overworked manager who keeps the office running, even if everyone else overlooks its efforts. Despite its size and challenges, Mercury holds a crucial place in our cosmic neighbourhood. As the English poet William Blake once mused, to see a world in a grain of sand and a heaven in a wild flower, so too does Mercury invite us to find wonder in the small and seemingly overlooked. So here's to Mercury, swift, shy, and endlessly fascinating. Venus, the solar system's glamorous but perpetually misunderstood sibling, draped in thick clouds of sulfuric acid, sweltering under a runaway greenhouse effect, and spinning in the wrong direction just to be difficult. It's as if Venus took one look at the family photo and decided to strike a pose all its own. With a diameter just shy of Earth's, Venus is often called our sister planet, but it's more of the hot-tempered cousin who insists on cranking the thermostat to unbearable levels. A planet where the surface temperature reaches a staggering 470 degrees Celsius, hot enough to melt lead, making it quite the hostile environment for any would-be visitors, tea drinkers or otherwise. Venus's atmosphere is a veritable cauldron of carbon dioxide, with clouds of sulfuric acid hanging thick and heavy, reflecting sunlight and creating an eerie golden haze. This dense atmosphere traps heat in a runaway greenhouse effect, turning Venus into a natural pressure cooker that's been simmering for millions of years. The crushing surface pressure is about 92 times that of Earth's at sea level. Imagine standing beneath nearly a kilometre of water. And yet, beneath these oppressive conditions lies a landscape of rolling plains, volcanic mountains, and vast lava fields. Venus boasts more volcanoes than any other planet in the solar system, with over 1,600 major volcanic structures mapped, some of which may still be active, a true inferno of geological activity. Venus also spins backward compared to most planets, a curious quirk known as retrograde rotation. A day on Venus, one full spin, takes about 243 Earth days, which is longer than its year of 225 Earth days. So, its sunrises and sunsets are the opposite of what you'd expect, giving the phrase turning back time a whole new planetary meaning. Venus's clouds are a swirling acidic mystery. Picture a sky so thick with yellowish clouds that they hide the surface completely from view. These clouds are composed primarily of sulfuric acid droplets, not exactly the kind of mist you want to get caught in on a leisurely stroll. They're dense, highly reflective, and churn constantly in a high-speed jet stream that races around the planet at over 360 kilometers per hour, much faster than Venus itself rotates. The perpetual cloud cover gives Venus a soft, diffuse glow when seen from space, a glowing orb wrapped in a thick golden shawl. It's tempting to think of it as a celestial mist, almost poetic if it weren't so deadly. This eternal cloud cover traps heat in a vicious greenhouse cycle, making the planet's surface hotter than Mercury's, despite being nearly twice as far from the Sun. If you're a fan of Star Wars, you might picture Venus's cloud tops as something like the legendary cloud city on Bespin, that floating metropolis perched among swirling mist and sky. Of course, Venus's clouds are far less hospitable, being filled with corrosive acids and relentless storms, but the idea of a city drifting amidst endless clouds hidden from view feels strangely apt. Interestingly, NASA's Magellan spacecraft used radar to peer beneath those clouds in the early 1990s, revealing detailed topography of Venus's surface. It's like having X-ray vision, unveiling volcanic plains, towering mountains, and vast lava flows hidden beneath the yellow fog. The images are hauntingly beautiful, a landscape of alien grandeur beneath a poisonous sky. Exploration of Venus has been a saga of daring and ingenuity. Early flybys by NASA's Mariner missions in the 1960s offered tantalizing glimpses beneath the clouds. The Soviet Venera program took the bold step of sending probes that actually landed on the surface, enduring searing heat and crushing pressure for brief moments to send back the first images of Venus's rocky face. I often imagine the bravery of those early spacecraft, metal capsules braving hellish conditions so we could understand this fiery sibling better. It's a reminder that exploration is often about pushing boundaries and embracing discomfort for the sake of knowledge. Venus remains a fascinating study in contrasts, a sister planet with a surface as hostile as a furnace, yet cloaked in clouds that have inspired countless myths and legends. As the old saying might go if anyone dared to say it, sometimes family members are difficult, but you wouldn't be yourself without them. Earth, the tea-drinking Goldilocks. Earth is a marvel of balance and complexity. Its atmosphere is a delicate cocktail of nitrogen, oxygen and trace gases that not only support life but create the blue skies and fluffy clouds that have inspired poets and painters for centuries. This gaseous envelope also acts as a protective blanket, shielding us from harmful solar radiation and meteoroids that dare to enter our realm. One of Earth's most defining features is its abundant liquid water. Oceans, lakes, rivers, and underground reservoirs that cycle relentlessly through evaporation, condensation, and precipitation. This water cycle is the lifeblood of the planet, driving weather patterns, nourishing ecosystems, and shaping landscapes. It's the gentle rhythm that sets Earth apart, a constant movement that breathes life into every corner. The biosphere, that vast tapestry of living organisms from microscopic plankton to towering redwoods and curious humans, thrives thanks to this balance of atmosphere and water. Earth is the only known planet where life not only exists but actively transforms its environment, oxygenating the atmosphere, sculpting soils, and even influencing climate patterns. Our planet's place in the vast cosmos was famously captured by Carl Sagan in his reflections on the pale blue dot. From the distant gaze of the Voyager, one spacecraft, Earth appears as a tiny fragile speck suspended in a sunbeam, a reminder of our shared vulnerability and the preciousness of our home. Sagan's words invite us to humility and stewardship. Look again at that dot. That's here, that's home, that's us. Speaking of Voyager, humanity's ambassadors to the stars, we sent those intrepid spacecraft carrying a message for any curious cosmic neighbours. Attached to each Voyager is the Golden Record, a phonograph of sorts, containing greetings in dozens of languages, music from Bach to Chuck Berry, natural sounds from whale songs to thunder, and images portraying life on Earth. It's our cosmic mixtape, a time capsule of humanity's essence, hurtling through the void with hopes that someday, somehow, someone might listen. I often think about that. The idea that among the cold stars and silent expanses, a tiny golden disc spins, bearing our stories, our music, and a snapshot of our humanity. It's a profound testament to our desire to connect, to be remembered, and to reach beyond our pale blue dot. Earth's magnetic field, generated by its molten iron core, is another crucial protector. It deflects charged particles from the solar wind, creating the spectacular auroras near the poles, nature's own light show. These shimmering curtains of green and red light remind us that Earth is not just a passive rock, but a dynamic, living world. Yet Earth is not without its quirks and chaos. From earthquakes and volcanoes to hurricanes and droughts, it's a planet of constant change and occasional upheaval. But perhaps this unpredictability is part of what makes Earth so endearing, a reminder that life thrives not in stillness, but in the dance of change. One cannot overlook Earth's geological dynamism. The movement of tectonic plates crafts mountains, earthquakes, and the shifting landscapes we call home. It's a restless planet, alive beneath the surface, reminding us that the ground beneath our feet is far from static. From a personal perspective, I find Earth endlessly fascinating and comforting. As I sip my tea and gaze out a window, I'm reminded of the intricate web of life and the fragile balance that sustains it. The rustling of leaves, the gentle flow of rivers, the chorus of birdsong, all signs of a planet humming with vitality. Earth may be just one planet among many, but it's home, a unique and treasured member of our cosmic family. The Moon, Earth's ever-faithful companion, the loyal sidekick who never quite steals the spotlight, but without whom the whole cosmic drama would feel a little empty. Orbiting our planet in a gravitational embrace, it's been both muse and mystery for humankind, inspiring everything from poetry to pop culture, science to superstition. At roughly 1/4 the diameter of Earth, the Moon is surprisingly large compared to its planet, so much so that Earth and the Moon form a sort of cosmic dance duo, locked in a tidal tango that affects oceans, time, and even the length of our days. The Moon's origin story is a dramatic tale of cosmic collision. Roughly 4.5 billion years ago, a Mars-sized body named Theia slammed into the young Earth in a titanic impact. The debris from this celestial car crash coalesced to form the Moon, a fiery newborn companion born of chaos and chance. It's as if Earth needed a sidekick and built one from the wreckage of a spectacular accident. Rather a messy family history, but one that forged a bond lasting billions of years. Geologically, the Moon is a fascinating place. Its surface is a patchwork of ancient highlands and vast basaltic plains called maria, which early astronomers mistook for seas, hence the name. These maria are the result of ancient volcanic eruptions that flooded large basins with lava, creating smooth, dark expanses that contrast starkly with the rugged, cratered highlands. The Moon's surface bears scars from countless impacts. Giant craters and basins left by asteroids and comets, some so large they can be seen from Earth with the naked eye. The most famous of these, the Sea of Tranquility, is where Apollo 11 astronauts first set foot in 1969, a landmark moment that connected humanity forever to this celestial neighbour. The Moon doesn't just influence tides and tides alone, it also stabilises Earth's axial tilt, helping to regulate our climate over long timescales. Without the Moon's gravitational nudges, Earth's tilt might wobble wildly, leading to chaotic seasons, a recipe for planetary turmoil rather than tea and tranquility. The Moon isn't just a dusty rock to stare at wistfully, it's a proper character in the cosmic drama. Take its rather leisurely rotation. It spins so slowly that a single lunar day lasts about 29.5 Earth days. That means the sun lingers lazily in its sky, taking its sweet time to rise and set. Perfect for those who prefer their sunrises slow, and their sunsets even slower, though I imagine a lunar holiday would require an awful lot of patience and probably a very sturdy sun hat. And then there's the Moon's stubborn refusal to show us its far side, the famously mysterious dark side, which, as we discussed, is neither always dark nor particularly shy, just a tad private. Imagine if your nosiest relative were banned from peeking over the fence. It would drive the neighbourhood gossip mad. This far side is also the setting for some fascinating science. Because it's shielded from Earth's radio chatter, it's the perfect spot for radio telescopes that can listen to the whispers of the cosmos without interference. Some scientists dream of a lunar observatory there, a quiet outpost where we can eavesdrop on the universe's deepest secrets, far from earthly noise and distraction. Culturally, the Moon has been a muse for poets, musicians, and mad inventors alike. From the haunting melodies of Moon River to the whimsical wonder of the adventures of Tintin's explorers on the Moon, it's a celestial stage for imagination. Even the surreal Aquatine Hunger Force gave us the Mooninites, pixelated troublemakers from the Moon, who added a peculiar comedic twist to lunar lore. If you haven't seen them, imagine two blocky little aliens perpetually annoyed and plotting mischief from their cratered home. A reminder that the Moon's pop culture presence is as quirky as its craters. But before all this modern fascination, the Moon played an even more profound role in ancient history and religion. Across nearly every culture, the Moon was a symbol of time, change, and mystery. Its waxing and waning phases inspired early calendars and rituals, guiding agricultural cycles and spiritual ceremonies. In ancient Mesopotamia, the moon god Sin was revered as a regulator of time and the heavens. The Babylonians' lunar calendar governed everything from planting seasons to royal decrees. Similarly, the ancient Egyptians worshipped Khonsu, a moon god associated with healing and protection. The crescent moon symbol was a powerful emblem seen in their art and temple reliefs. The Greeks and Romans personified the moon as goddesses, Selene and Luna, respectively, often depicted riding chariots across the night sky. Selene was both a gentle nurturer and a fierce protector, embodying the dual nature of the moon's influence. In Hinduism, the moon god Chandra is associated with vegetation and fertility, while in Chinese mythology, Chang'e is the beautiful moon goddess who lives in eternal exile, inspiring tales of longing and immortality. The moon's role in folklore is as varied as the cultures that gaze upon it, from symbols of femininity and rebirth to omens and mysteries. The moon has also inspired countless poems and songs, the pale beacon of romantic nights, the silent witness to human hopes and fears. It's no surprise that Pink Floyd chose the evocative phrase "Dark Side of the Moon" for their iconic 1973 album, a sonic exploration of mental struggles and the passage of time, perfectly capturing the moon's aura of mystery and quiet power. Of course, the Apollo missions brought humanity face to face with the moon, transforming it from myth to measurable reality. The moon rocks brought back, the footprints left behind, and the scientific instruments placed on its surface have deepened our understanding and our appreciation for this steadfast companion. Personally, I find the moon's steady, silent presence comforting. As I look up on a clear night, its pale glow feels like an old friend keeping watch, a cosmic lantern in the vast dark. The moon reminds us that even in the enormity of space, companionship endures, a beacon of constancy in a universe that's ever-changing. Mars, often called the Red Planet, owes its distinctive colour to iron oxide, or as you might call it, rust, coating its surface. This rusty hue is the first thing that captures the imagination, painting Mars as the fiery sibling with a temper and a tail. But beneath that red dust lies a planet with a surprisingly rich and varied history. Once, billions of years ago, Mars was warmer and wetter, with flowing rivers, vast lakes, and possibly even oceans. Evidence from rovers and orbiters has revealed ancient riverbeds and minerals that only form in the presence of water. Imagine a world that might have been a watery paradise, now transformed into a cold desert, waiting patiently for its next chapter. Mars is also a planet of extremes. Its thin atmosphere can't hold much heat, so temperatures swing wildly, from a balmy 20 degrees Celsius at noon near the equator to a bone-chilling minus 125 degrees Celsius at the poles during winter nights. Dust storms can engulf the entire planet, sometimes lasting for months, cloaking Mars in a red haze and reducing sunlight to a dim twilight. Humanity's fascination with Mars is as old as recorded history. Named after the Roman god of war, Mars has inspired myths, legends, and countless works of fiction. From H.G. Wells' The War of the Worlds to modern sci-fi movies and TV shows, Mars has long been the canvas for our hopes, fears, and dreams about space colonization. The real exploration of Mars began in the 1960s with flyby missions, but it's the robotic explorers that have truly brought Mars closer to us. The Mars rovers, Spirit, Opportunity, Curiosity, and Perseverance have traversed its rocky terrain, analysed soil and rock samples, and sent back breathtaking images that make the Red Planet feel almost within reach. One of the great ironies of Mars exploration is how much we've learned about a planet many millions of kilometres away, yet so little about what exactly caused its once warm and watery past to turn cold and dry. It's a cosmic whodunit, with climate change on a scale so vast it boggles the mind. It's like finding a rusted teapot on a distant shore and wondering who left it there, or in the words of philosopher Bertrand Russell, wondering if that teapot even exists at all. Speaking of Russell's teapot, imagine explaining Mars' atmosphere to a skeptic. Well, you see, there's a tiny teapot orbiting Mars hidden just beyond our instruments. To which the skeptic replies, "Ah, yes, and while we're at it, why not add a golden biscuit factory on Phobos?" It's a reminder that in astronomy, as in life, extraordinary claims require extraordinary evidence, and Mars's evidence is delightfully substantial. Mars isn't just a cold, barren desert. It's a geological wonderland, home to Olympus Mons, the tallest volcano in the solar system, a staggering 22 kilometres high, nearly 3 times the height of Everest, and Valles Marineris, a canyon system so vast it would stretch across the United States, dwarfing the Grand Canyon. These features tell stories of violent geological activity that shaped the planet's surface. Mars also has polar ice caps made of water and dry ice, frozen carbon dioxide, growing and shrinking with the seasons. The presence of water ice is particularly tantalizing, fueling speculation about past life and future human colonization. The rovers have discovered organic molecules, the building blocks of life, and seasonal methane plumes that tantalize scientists with the possibility of microbial life still lingering beneath the surface. Whether Mars hosts life remains a mystery, but its potential keeps our imaginations alight. Culturally, Mars continues to captivate. It's the setting for countless novels, movies and TV shows, from the Martian story of survival against the odds to the epic voyages of John Carter of Mars. Its red glow has inspired poets and dreamers alike, symbolising both war and hope, desolation and adventure. Personally, I find Mars endlessly fascinating, a world of stark beauty and dramatic history, a symbol of human curiosity and resilience. Its deserts may be deserted, but its story is far from over. And perhaps, just perhaps, one day, a cup of tea will be brewed on Martian soil, shared among new explorers beneath a salmon-pink sky. Speaking of which, who could forget Elon Musk's rather audacious publicity stunt, sending his cherry-red Tesla Roadster hurtling into space, now making its leisurely way around the Sun, occasionally swinging past Mars. One imagines the Martians looking up, blinking their antennae in confusion, and wondering why an Earth car is cruising through their neighbourhood, playing David Bowie's Space Oddity on loop. A cosmic joyride, if ever there was one. The asteroid belt, cosmic crumbs and failed planets. Among the myriad rocks in the asteroid belt, a few stand out like the dignitaries of this rocky realm. Ceres, the largest, is a dwarf planet about 940 kilometres across. A rounded world in its own right, with signs of water ice beneath its surface and possibly even cryovolcanoes. That's volcanic activity not of molten rock, but of icy slush. Ceres is the aristocrat of the belt, quietly holding court amid the chaos. Then there's Vesta, a massive asteroid about 525 kilometres in diameter, with a varied landscape marked by huge craters and towering mountains. Vesta's surface is a patchwork of basaltic rock, evidence of ancient volcanic activity. NASA's Dawn spacecraft spent years orbiting both Vesta and Ceres, unveiling their secrets and showing us that these rocky bodies are far more than inert space rubble. Smaller asteroids like Pallas and Hygiea also merit mention. Pallas, roughly 512 kilometres across, is oddly tilted on its axis, adding a bit of cosmic flair to its rotation. Hygiea, about 430 kilometres wide, was recently promoted to dwarf planet status, reminding us that classification in astronomy is as much about evolving understanding as it is about labels. The asteroid belt has captured the imagination beyond science. Mythologically, many asteroids bear the names of gods, goddesses, and legendary figures, a nod to humanity's desire to connect the heavens with our stories. From Juno, the Roman goddess of marriage, to Vesta, the virgin goddess of the hearth, these names echo our cultural heritage across the vastness of space. In pop culture, the asteroid belt is often portrayed as a dangerous minefield of tumbling rocks, a convenient obstacle course in sci-fi adventures. The reality, however, is more serene. The asteroids are spaced so far apart that a spacecraft could navigate through without too much trouble, though the idea of dodging rogue space rocks will forever fuel dramatic storytelling. One might say the asteroid belt is a bit like a giant cosmic portion of fish and chips, a seemingly chaotic pile of battered and fried bits, yet each piece distinct, with its own flavour and story, some crunchy and ancient, others soft and fresh, all part of a delightful if somewhat messy cosmic meal. The asteroid belt reminds us that even the leftovers of creation are vital pieces of the cosmic puzzle. They tell stories of destruction and survival, of gravitational dance and celestial evolution. It's a place where chaos meets order, and where the ancient history of our solar system waits patiently to be uncovered. Jupiter, enormous, gassy, and fond of accessories. Jupiter is the heavyweight champion of the solar system, a true giant among planets. Its sheer size and mass are staggering. It's so massive that it holds more than twice the combined mass of all the other planets put together. This colossal sphere is mostly made of hydrogen and helium, the same elements that make up our Sun, making Jupiter more of a failed star than a typical planet. But fear not, this gas giant isn't about to ignite and brighten our nights anytime soon. It simply lacks the necessary mass for fusion, so it remains our majestic, swirling behemoth. Beneath Jupiter's vibrant bands of orange, white and brown clouds lies a bizarre and exotic interior. At incredible pressures and temperatures, hydrogen transitions into a metallic state, essentially a liquid metal that can conduct electricity. This metallic hydrogen ocean is responsible for Jupiter's gargantuan magnetic field, the largest and most powerful in our solar system. Stretching millions of kilometres into space, Jupiter's magnetosphere acts like an invisible shield, protecting its moons from solar winds, but also creating a harsh environment filled with intense radiation. If you ever fancied a trip near Jupiter, you'd best pack a very sturdy spacesuit. Now, if Jupiter were a royal monarch, then its moons are its sprawling court, a grand assembly of more than 95 known satellites, with more discovered every few years as our telescopes and spacecraft get better. Among this entourage, the 4 Galilean moons, Io, Europa, Ganymede and Callisto, are the crown jewels, discovered by Galileo Galilei way back in 1610. These moons alone offer a universe of intrigue and wonder. Io, the innermost of the 4, is the most volcanically active body in the entire solar system. Its surface is dotted with hundreds of volcanoes that spew sulfur and lava, painting it with vibrant yellows, reds and oranges, a fiery spectacle that rivals any earthly volcano show. Io's intense volcanic activity is driven by tidal heating, caused by gravitational tugs from Jupiter and neighbouring moons, making it a cosmic cauldron of molten rock. Europa, slightly smaller than Earth's moon, hides a global ocean beneath its icy crust. This subsurface ocean could contain twice as much water as all of Earth's oceans combined. Scientists speculate that this hidden sea might harbour conditions suitable for life, making Europa one of the most exciting targets for astrobiology and future exploration. Imagine a frozen world with a vast dark ocean teeming with alien microbes or even more complex life. A real-life sci-fi dream. Ganymede, the largest moon in the solar system, is a world unto itself. Larger than the planet Mercury, Ganymede boasts its own magnetic field, a rarity among moons, and an icy surface marked by a complex history of tectonic and volcanic activity. It's a colossal world, with mountains, valleys, and possibly a salty ocean beneath its crust. Callisto, the outermost of the Galilean moons, wears a heavily cratered surface that speaks of a long and quiet history, untouched by geological upheaval. Its ancient terrain is like a cosmic museum, preserving the scars of countless impacts over billions of years. But Jupiter's moon family extends well beyond these four giants. Smaller moons like Amalthea, Thebe, and Himalaya form a motley crew of irregular satellites with unique orbits and characteristics. These moons are likely captured asteroids, each adding to the rich tapestry of Jupiter's domain. Jupiter also sports a faint but fascinating system of rings, composed mostly of dust kicked up by micrometeoroid impacts on its inner moons. Unlike Saturn's dazzling rings, Jupiter's are subtle and elusive, more of a whisper than a shout, yet they add to the planet's regal appearance. Culturally, Jupiter has been a symbol of power, authority, and majesty across civilizations. Named after the Roman king of gods, Jupiter embodies leadership and strength. It has inspired artists, poets, and musicians, with trains drops of Jupiter beautifully capturing the planet's mystique and allure, reminding us that even in the vastness of space, there's room for beauty and wonder. In many ways, Jupiter is the ultimate cosmic host, a tempestuous and magnificent figure surrounded by loyal moons, swirling storms and faint rings. Its grandeur and complexity command both awe and curiosity, inviting us to explore and marvel at the largest family member of our solar system. Europa, Ganymede and friends, Jupiter's rowdy moon club. Ah, the Galilean moons. Europa, Ganymede, Callisto and the ever-fiery Io, a rambunctious group that keeps Jupiter entertained and indeed keeps astrophysicists like myself endlessly fascinated and occasionally bemused. I recall one chilly evening at Cambridge, gazing through a modest telescope, attempting to glimpse the moon's dance around Jupiter. With my tea cooling beside me and a pile of research papers looming, I found myself entranced by these celestial bodies, each with its own personality and secrets, much like a lively dinner party where everyone talks over each other, yet the conversation never dulls. Of course, back home, my dog and my rather excitable rabbit, both named Jupiter, a nod to my obsession naturally, tend to bark and thump their feet whenever the actual planet Jupiter graces the night sky. It's as if they're staking claim, reminding me that this giant isn't just a distant orb but part of the family, deserving of their own raucous welcome. Now these four moons each bring their own flair to the cosmic soiree. Io, the fiery troublemaker. With over 400 active volcanoes, it's the most volcanically active body in the solar system. Imagine a world where the ground literally bubbles and erupts, showering sulphurous plumes hundreds of kilometers high. Io's relentless geological activity is driven by tidal forces, squeezed and stretched by Jupiter's immense gravity, and the gravitational tugs from its neighbouring moons. It's a cosmic pressure cooker, a place of spectacular, violent beauty. Europa, the icy enigma. Slightly smaller than our moon, Europa hides a global ocean beneath its cracked icy shell. This subsurface sea, kept warm by tidal flexing, is one of the most promising places to search for extraterrestrial life. I like to imagine tiny alien microbes waltzing in its dark, salty depths, a vast alien ocean world hidden from our gaze. Europa's smooth, bright surface is crisscrossed by streaks and ridges, hinting at a dynamic crust that might occasionally let that ocean water peek through. Ganymede, the giant sibling, the largest moon in the solar system, bigger even than Mercury, Ganymede boasts its own magnetic field, a rarity for a moon. Its surface is a patchwork of older, heavily cratered regions and younger grooved terrain, evidence of a complex geological history. Beneath its icy shell it may harbour an ocean deeper than Europa's, wrapped in layers of ice and rock. Callisto, the elder statesman. Callisto is heavily cratered and ancient, its surface a scarred testament to billions of years of cosmic impacts. Unlike its more geologically active siblings, Callisto's surface has remained relatively unchanged, a serene and solemn witness to solar system history. Its remoteness and calm might make it a quieter place to explore, though just as fascinating. Together, these moons form a rowdy celestial club, each member unique yet bound by their shared dance around the giant Jupiter. Their interactions, gravitational tugs, tidal heating, and orbital resonances create a complex ballet that keeps the entire system lively. Studying this moon club has been one of the highlights of my career. I remember a particularly memorable lecture where I tried to explain Europa's ocean to a rather sceptical audience. As I waxed lyrical about possible alien life beneath the ice, a student quipped, "So, it's basically an interplanetary swimming pool for extraterrestrials." I think I smiled, then nodded. Why not? It's a wonderfully vivid way to think about it. The Galilean moons are not just scientific curiosities, they are beacons of possibility. Their dynamic environments challenge our understanding of habitability and push us to expand our search for life beyond Earth. And so, each night as I watch Jupiter's bright orb climb the sky, I think of my dog and rabbit barking joyously, the volcanic fury of Io, the icy mysteries of Europa, the colossal grandeur of Ganymede, and the ancient calm of Callisto. It's a reminder that our solar system is not just a collection of rocks and gas, but a lively, interconnected family full of wonder. Saturn, the stylish giant. Saturn's rings, the solar system's ultimate bling, its cosmic tiara, its sparkling halo of grandeur. Picture this, a planet so large it could fit over 750 Earths inside, yet it's the rings that steal the show. It's a bit like turning up to a fancy gala in an ordinary tuxedo only to be outshone by your aunt's gigantic feathered hat. You think, right, that's going to be hard to top, and Saturn just casually spins, "Hold my ring." These rings are made up of trillions of particles, everything from microscopic ice dust to chunks large enough to house a modest family of Martians, should they ever get a chance to move in. And yet, despite this vastness, these rings are thin enough that if Saturn were to sneeze, the whole lot might scatter like a cosmic deck of cards, leaving us staring at a suddenly rather naked gas giant. One imagines the rings tutting indignantly, "Oh, honestly, can't a planet enjoy a bit of sparkle in peace?" Now these rings are divided into sections with very unromantic names. The A ring, B ring, C ring and so forth. It's not quite the glitzy chandelier room or diamond hall, but I suppose when you're dealing with planetary geology, one must take what one can get. The most famous gap, the Cassini division, is a clear band caused by the gravitational nudging of the moon Mimas, who apparently fancies himself the solar system's bouncer. One can imagine Mimas standing at the velvet rope shaking a cosmic fist. No riffraff in the ring tonight. The particles themselves are constantly bumping and crashing, but not with the dramatic violence one might expect. It's more a polite London party, where people accidentally jostle each other in the tight space, apologise profusely, and then continue sipping their cosmic cocktails. This delicate balance keeps the rings from either collapsing into a blob or scattering into space. A celestial dance of chaos and order that would make even the most seasoned ballroom dancer dizzy. Shepherd moons, those celestial bodyguards, patrol the edges of the rings. Prometheus and Pandora, two of Saturn's smaller moons, keep the F-ring in check with their gravitational antics, causing knots and kinks that ripple through the icy particles. It's like watching a cosmic game of cat and mouse, except the cats and mice are billions of kilometres wide and made of rock and ice. There's also the enduring mystery of the rings' origin. Were they formed from a moon that got a little too close and was spectacularly dismembered? Or are they ancient leftovers from the planet's formation? Recent data suggests the rings might be relatively young. Perhaps the solar system's most dazzling fashion statement made just a few 100 million years ago. Compared to the Earth's 4.5 billion years, That's basically ring adolescence. Of course, these rings aren't permanent. Over millions of years, they're slowly raining material onto Saturn itself, in a phenomenon astronomers poetically call ring rain. One imagines Saturn sighing as it watches its glittering accessories wash away, mumbling, "Well, I suppose nothing lasts forever, not even fabulousness." I vividly remember the first time I peered at Saturn through a telescope. Not the enormous observatory kinds, but a modest instrument I borrowed from a friend. Even then, those rings were unmistakable, like a cosmic wedding band shimmering in the dark. It was a moment of pure, unadulterated wonder, the kind that reminds you that no matter how many problems we humans have, the universe will keep dazzling us with its absurdly beautiful spectacles. So, dear listener, the next time you gaze up at the night sky and spot Saturn, spare a thought for those rings. Fragile, fleeting, and fabulously fabulous. And if you happen to be a planet, perhaps invest in a better security system to keep your rings from falling off. Titan and Enceladus, the solar system's moody moons, each with its own eccentric personality and a flair for the dramatic. Titan, draped in a thick orange haze, sports an atmosphere so dense and peculiar that it's the only moon in our cosmic neighbourhood with a proper atmosphere to speak of. Its surface hosts lakes and rivers, not of water, mind you, but of liquid methane and ethane. That's right. Methane, usually a gas on Earth, flows freely here in liquid form thanks to Titan's chilly temperatures and thick atmosphere. So imagine a world where rain falls as liquid methane, carving valleys and filling lakes much like water does on Earth, but with a distinctly alien twist. And yes, the air carries a faintly rebellious fart cloud aroma, making Titan the solar system's answer to a pub after a particularly lively evening. As my grandmother might have said with a sniff and a wink, "Well," I say, "if Titan's air was any more pungent, it'd have its own postcode." But don't let the smell put you off. Titan is a fascinating place, with dunes, hills, and possibly cryovolcanoes that spew icy slush instead of molten rock, making Titan both strange and strangely familiar. Meanwhile, Enceladus prefers a more theatrical display. It erupts with towering geysers of water ice from fractures near its south pole, sending plumes of vapour hundreds of kilometres into space. These spectacular jets hint at a subsurface ocean warmed by tidal heating, a potential haven for life beneath its icy shell. It's as if Enceladus is saying, "Yes, I'm cold on the outside, but I've got a warm heart, and a bit of a flair for the dramatic." I remember once trying to explain Enceladus's plumes to a particularly grumpy colleague who muttered, "So it's basically a giant space seltzer." "Spot on," I replied, imagining tiny alien microbes fizzing about in its hidden ocean. These moons aren't just scientific curiosities, they're vital pieces in the puzzle of planetary habitability. Titan's thick atmosphere and organic chemistry offer clues about prebiotic conditions, while Enceladus's subsurface ocean tantalizes us with the possibility of extant life. Both moons remind us that the solar system is full of surprises, places where conditions can be bizarrely hospitable despite appearances. So, as you ponder these moody moons, perhaps raise a cup of tea in their honour. After all, where else could you find a place with lakes of liquid methane and a moon that sneezes icy jets into the void? Only in our wonderfully weird cosmic backyard. Uranus, the solar system's cheeky oddball, spinning on its side like a tipsy ballerina and sporting an atmosphere that, well, has been said to smell rather like, well, let's just say a less than pleasant whiff of hydrogen sulfide. Yes, the cosmic equivalent of someone letting one rip in a crowded elevator, but on a planetary scale. This icy giant's unique tilt, a staggering 98 degrees, means it essentially rolls around the sun like a cosmic rugby ball, rather than spinning upright like its planetary siblings. For decades at a time, one pole basks in continuous sunlight while the other languishes in darkness. You'd think this kind of rotation would throw a party of strange weather and eccentric seasons, and you'd be right. Imagine having 6 years of summer followed by 6 years of winter. And no, you can't just wear a jumper and flip-flops. Uranus's atmosphere is mostly hydrogen and helium, but with a fair helping of methane that gives the planet its signature pale blue-green hue. That methane is excellent at absorbing red light, reflecting the blue and green, which makes Uranus look like the ultimate cosmic turquoise gem. But that same methane also contributes to those infamous smells, as it combines with hydrogen and sulfur to produce hydrogen sulfide, the notorious stinker. When Voyager 2 flew past Uranus in 1986, it detected this hydrogen sulfide signature, leading to many a snigger among scientists and the odd eyebrow raise from the public. After all, it's not every day a planet earns a reputation for smelling like rotten eggs, though in space, we suppose it's best not to hold your breath. Uranus also boasts a retinue of 27 known moons, each named mostly after characters from Shakespeare and Alexander Pope, lending a certain literary flair to its cold, distant system. From the mysterious Miranda with its jumbled terrain that looks like it's been through some cosmic landscaping gone wrong, to Titania and Oberon, regal moons that quietly circle their oddball parent. The name Uranus itself comes from the ancient Greek deity Uranos, the primordial sky god who personified the heavens. According to myth, Uranos was both father and consort to Gaia, Mother Earth, and their turbulent relationship gave birth to the Titans. Uranus's castration by his son Cronus, a grisly tale told by Hesiod, marks one of the more dramatic cosmic family dramas, a reminder that even the heavens had their messy moments. It's only fitting that a planet with such a chaotic tilt and peculiar atmosphere bears the name of such a tempestuous figure. Uranus is the celestial embodiment of eccentricity and upheaval, a reminder that the cosmos isn't always neat and orderly. Culturally, Uranus has long been the butt of cosmic jokes, no pun intended, but its peculiarities are what make it so fascinating. As a proper British professor, I can't help but admire its cheekiness, and the fact that even in the grand, orderly dance of planets, there's always room for a bit of sideways mischief and the occasional planetary punchline. Neptune, the solar system's furthest known planet, a distant azure world where the winds howl with a ferocity unmatched anywhere else in our cosmic neighbourhood. Imagine standing on its cloud tops if you dare, and feeling gale-force storms blasting at speeds of up to 2,000 kilometers per hour. That's fast enough to turn your umbrella inside out and send your bowler hat into orbit, all before you've even had a chance to say pip pip. The very idea of Neptune's storms makes one think of the fiercest winds you've ever experienced on Earth, the kind that force you to cling to lampposts, send hats flying, and leave your umbrella in tatters. Now multiply that by 10, throw in an atmosphere mostly of hydrogen, helium and methane at incredibly low temperatures, and you get a tempest so relentless it could humble even the most stoic of Britons. The most famous of Neptune's storms is the Great Dark Spot, a high-pressure system roughly the size of Earth itself, first spotted by Voyager 2 in 1989. This colossal vortex churns with winds exceeding 2,100 kilometers per hour, fast enough to circle the planet in mere hours. The storm's mysterious disappearance and occasional reappearance remind us that Neptune's weather is as enigmatic as the distant blue globe itself. One can only speculate what it would feel like to stand under such a storm. Imagine the sky painted in deep blues and inky blacks, punctuated by lightning flashes illuminating swirling clouds of methane ice crystals. The air would be bitterly cold, hovering around minus 220 degrees Celsius, freezing even the most daring explorer's eyelashes mid-blink. No amount of thermals or woolly jumpers would suffice in such an environment. I recall reading accounts from Voyager 2's flyby, and feeling both awe and a peculiar sort of dread. Here was a world so beautiful in its cobalt glory, yet so utterly inhospitable, a reminder that the universe can be breathtakingly lovely and terrifying all at once. Neptune's position as the outermost giant makes it something of a cosmic loner. It receives only a faint whisper of sunlight, about 1/900th the intensity Earth enjoys, making its distant orbit a realm of twilight and shadows. Yet, despite this remoteness, Neptune radiates more heat than it receives from the Sun, a phenomenon scientists attribute to residual heat from its formation and slow gravitational contraction. This internal heat fuels its wild weather systems and possibly maintains layers of oceans beneath its thick gaseous envelope. These hypothetical oceans might be exotic mixtures of water, ammonia and methane under crushing pressures, alien seas utterly unlike anything on Earth. Now, about Neptune's orbit. It's not your everyday, neat and tidy circle. Neptune's orbit is slightly eccentric, meaning it isn't a perfect circle but a stretched ellipse, and that eccentricity sets the stage for some fascinating interactions, especially with Pluto. For 20 years of Pluto's 248-year orbit, the The smaller dwarf planet is actually closer to the Sun than Neptune, cruising inside Neptune's orbit in a cosmic game of leapfrog. But don't worry, the two never get close enough to cause trouble, thanks to a neat orbital resonance dance that keeps them well apart, like distant cousins politely avoiding awkward family reunions. Neptune's gravity also shepherds many objects in the Kuiper belt, a distant region of icy bodies beyond Neptune, influencing their orbits and keeping the outer solar system in a delicate gravitational balance. It's as if Neptune is the cosmic bouncer, keeping order at the edge of the planetary club. Neptune's moons add to its solitary charm. Triton, its largest moon, is a cold, geologically active world with geysers of nitrogen ice that spew plumes into space, giving it an eerie, otherworldly glow. Triton orbits Neptune backwards, a celestial rebel defying the norm, possibly a captured Kuiper belt object, which only adds to Neptune's enigmatic reputation. From a cultural perspective, Neptune's name and mythological roots invoke the vast, mysterious oceans of Earth, fitting for a planet shrouded in deep blues and tempestuous weather. Neptune, the Roman god of the sea, was both powerful and unpredictable, traits mirrored in the planet's atmospheric behaviour. Personally, I find Neptune to be the ultimate embodiment of the lonely wanderer, spinning on the edge of our solar system. Its storms, its moons, and its mysteries beckon the curious and the brave to look beyond the familiar, to embrace the unknown. So next time you gaze up at the night sky, spare a thought for Neptune, the windy loner, a distant blue jewel of storms and secrets, whispering tales of the farthest reaches of our cosmic family. Ah, Pluto. Once the 9th planet, now the solar system's most famous dwarf planet, and arguably the most misunderstood family member of our cosmic clan. You know the type. Once the star of the show, then politely but firmly told, you're not really a planet anymore, and shown to a cosy little sitting room away from the main dining table. But Pluto, bless its icy heart, has taken this demotion with quiet dignity and an enduring sparkle. Discovered in 1930 by Clyde Tombaugh, Pluto captured the imagination of scientists and the public alike. For decades, it was the smallest and most distant planet, a mysterious frosty world orbiting far beyond the gas giants. But as telescope technology improved, astronomers discovered a whole crowd of similar icy bodies lurking in the Kuiper belt, a vast ring of debris and dwarf worlds beyond Neptune. The existence of this populous neighbourhood eventually led to Pluto's demotion to dwarf planet status in 2006, a move that sparked debates as heated as any British parliamentary session. Pluto's orbit is rather eccentric and tilted, bringing it sometimes closer to the Sun than Neptune, a cosmic dance that only adds to its uniqueness. Its surface is a patchwork of nitrogen ice plains, methane frosts, and towering mountains of water ice, painted in subtle shades of white, red, and brown. The heart-shaped Tombaugh Regio, named after its discoverer, is a vast nitrogen ice plain that looks surprisingly Earth-like, evoking thoughts of polar landscapes and frozen deserts. In 2015, NASA's New Horizons spacecraft gave us the first up-close look at Pluto, revealing astonishing details and a surprisingly complex world. Its mountains rise over 3 kilometers high, its atmosphere is a tenuous haze of nitrogen and methane, and it boasts at least 5 moons, with Charon being the largest and almost a partner in a cosmic pas de deux. The Kuiper belt itself is a sprawling, icy frontier, home to countless small bodies, many yet to be explored. It's a region rich with clues about the early solar system, a fossil record preserved in ice and rock. Beyond Pluto lie even more distant objects like the mysterious Sedna and the enigmatic Eris, the dwarf planet whose discovery prompted Pluto's demotion. Pluto and its Kuiper belt neighbours remind us that our solar system is a dynamic, evolving family, full of surprises and complexities. Though exiled from planetary status, Pluto remains a beloved and fascinating world, a reminder that even the underdogs have stories worth telling. As we ponder Pluto's tale, perhaps we might raise a metaphorical toast, or better yet a cup of tea, to this exiled royal, still shining in the cold depths of space with grace, mystery and a dash of stubborn charm. The Oort cloud, the most mysterious and elusive member of our solar system's sprawling family. It lurks at the very edges of our cosmic neighbourhood, a vast spherical shell of icy bodies that form a kind of cosmic hedge, protecting our planetary garden from the cold void beyond. If the planets are the well-mannered relatives gathered around the dining table, the Oort cloud is that eccentric great-aunt living in a remote cottage miles away, who only sends postcards occasionally, usually in the form of comets. The Oort cloud is thought to begin at around 2,000 astronomical units from the Sun and stretch out to somewhere near 100,000 astronomical units, roughly a quarter of the way to the nearest star, Proxima Centauri. To put that in perspective, if our entire solar system were a dinner plate, the Oort cloud would be the thin dusting of sugar on the edge of the table, barely noticeable, yet infinitely important. It was first proposed in the mid-20th century by the Dutch astronomer Jan Oort, who was trying to explain the origin of long-period comets, those rare, spectacular visitors with orbits lasting thousands or even millions of years. These comets show up unexpectedly, blazing bright and often inspiring awe, and, admittedly, a fair bit of panic throughout history. The objects in the Oort cloud are icy and ancient, primordial leftovers from the solar system's formation over 4.5 billion years ago. They were likely formed closer to the Sun, but gravitational tugs from the giant planets, especially Jupiter and Saturn, hurled them outward to these distant frozen frontiers. Out there, in the deep freeze, they remain largely untouched by time, silent and solitary. Yet, despite this remoteness, the Oort cloud occasionally sends a visitor inward. Gravitational nudges from passing stars or the tidal pull of our galaxy itself can disturb these icy bodies, sending them careening toward the Sun. When they approach, the Sun's heat causes their ices to vaporize, creating the spectacular glowing tails that light up our skies. These celestial wanderers are the long-lost cousins who finally come to visit the family gathering, albeit briefly and dramatically. Interestingly, the Oort cloud itself has never been directly observed. It's a place inferred from the orbits and behaviours of these comets, an invisible cloud whose existence is hinted at by the cosmic clues left behind. It's a bit like deducing the presence of a distant relative based on the mail they send, a letter here, a package there, without ever having met them in person. Scientifically, the Oort cloud serves as a crucial part of the solar system's architecture. It acts as a reservoir for comets, replenishing the inner solar system with these icy time capsules that offer insights into the earliest days of planetary formation. The cloud's structure, a roughly spherical distribution of objects, suggests a dynamic history shaped by countless gravitational interactions and cosmic events. What's delightful about the Oort cloud is its poetry. It's the ultimate expression of cosmic loneliness and mystery. It's the final frontier of our solar system, a place where the Sun's gravitational influence fades into the galactic background, where the solar system's reach gently brushes against the vast interstellar sea. So, when you next spot a bright comet streaking across the night sky, remember that it may have come from this distant, icy wilderness. It's a reminder that even in the deepest shadows of space, our solar system's family ties reach far and wide, binding together worlds seen and unseen, near and far, known and unknown. Gather round, dear listeners, as we travel back over 4.5 billion years to the great cosmic cook-up that gave birth to our solar system. A swirling, chaotic dance of dust, gas and gravity that somehow, against all odds, led to the glorious ensemble we know today. Imagine, if you will, a vast molecular cloud, a chilly, diffuse gathering of hydrogen, helium and a sprinkling of heavier elements, drifting quietly in our Milky Way galaxy. This cloud, like a sleepy cat curled up in a sunbeam, might have remained undisturbed for eons if not for a passing disturbance. Perhaps the shockwave from a nearby supernova, or the gravitational tug of a wandering star. This disturbance stirred the cloud, causing it to collapse under its own gravity, spinning faster and flattening into a disk, the protoplanetary disk, much like a cosmic pancake, only a bit hotter and less edible. At the centre, the sun ignited, lighting the stage for the planets to begin their intricate dance. Within this spinning disk, dust grains collided and stuck together, slowly building up into larger and larger clumps. Some became pebbles, then boulders, and eventually massive planetesimals, the building blocks of planets. It was a messy process filled with crashes, near misses, and countless cosmic near-deaths. Over millions of years, these planetesimals grew by attracting more material, their gravity pulling in dust, ice and rock like cosmic vacuum cleaners. Some grew into the rocky terrestrial planets, Mercury, Venus, Earth, and Mars, while farther out, cooler conditions allowed gas giants like Jupiter and Saturn to form thick atmospheres, ballooning in size. This formation was not without drama. The young solar system was a chaotic playground, with planets migrating, colliding, and even ejecting smaller bodies out into the void. The Earth itself might have suffered a colossal collision with a Mars-sized body, giving birth to our moon in a fiery celestial dance. Amidst this chaos, the leftover debris formed belts of asteroids and comets, including the Kuiper Belt and the distant Oort cloud, cosmic breadcrumbs that hint at the story's messy beginnings. It's a tale of cosmic folly as much as of cosmic order, a reminder that our orderly solar system today emerged from a chaotic, noisy, and downright explosive youth. And isn't that a comforting thought? That even in the vastness of space, a bit of chaos can give rise to beauty, and that behind every elegant orbit is a tale of collisions, explosions, and stubborn persistence. As our journey through the solar system's eccentric family draws to a close, let us take a moment for a farewell tour, a glimpse into the future of these celestial relatives, and of course, our own story amidst the stars. The planets and moons we've met are not frozen in time. They are dynamic worlds, ever-changing and full of surprises. Mars, with its dusty deserts and tantalizing hints of water ice, beckons as the most likely candidate for human colonization beyond Earth. Imagine sitting down with a cup of tea on the Martian plains, the red dust swirling gently in the low gravity, while robotic rovers continue their tireless explorations nearby. The Moon, our closest companion, is poised for a renaissance. Plans for lunar bases, mining helium-3, and deep space launch pads may soon turn our silver satellite into a bustling outpost, bridging Earth and the cosmos. Robotic explorers will continue to venture farther into the Kuiper Belt, the Oort cloud's mysterious depths, and perhaps beyond our solar system itself. The Voyager probes, now sailing through interstellar space, are our ambassadors to the stars, carrying messages on golden discs, symbols of our curiosity and hope. Our understanding of these worlds is still in its infancy. Future missions may uncover signs of life on Europa or Enceladus, or unravel the secrets hidden beneath Titan's hazy atmosphere. The gas giants, with their storms and moons, will remain subjects of fascination and study for generations to come. Of course, the solar system's distant future is written in slow, cosmic time. The sun will eventually exhaust its fuel, swelling into a red giant and transforming the planetary family in dramatic ways. But for now, we sit comfortably in this golden age of exploration, sipping our tea and marvelling at the beauty and complexity of our cosmic home. So, dear listener, as you close your eyes and drift off to sleep, may the tales of planets, moons, and cosmic wanderers lull you gently, reminding you that the universe is vast, strange, and ever-inviting. And perhaps one day, we'll share that cup of tea under alien stars, and as always, mind the damp, bring a biscuit, and never ever try to outstare a puffin. Until next time, sleep well, dream deeply, and may your teacup never be empty. And so, dear listener, as the last of the teacups cools and Pig begins to snore most contentedly on the windowsill, we come to the end of tonight's tale. If you've enjoyed this little ramble through the improbable and the quietly profound, do be a dear and like the episode and subscribe to the channel. It helps keep the tea flowing, the lights low, and the cats, both remembered and yet to be, well fed and purring. And don't forget, you're warmly invited to join our free Substack. It's where you'll hear about each new episode as it arrives, and where our growing circle of sleepy science enthusiasts gathers to swap thoughts, dream up topics, and gently bicker about whether Pluto should bring a casserole to the next planetary reunion. Now, one last thing. Tonight's story has been for entertainment purposes only. It is not, strictly speaking, fact. Nor is it entirely fiction. Rather, it exists in that peculiar quantum superposition of the two until observed, preferably over a cup of something warm. Sleep well, and until next time, may your teacup never be empty.